Unit 3, Day 4 notes. Here we go. They have started us off with a 30, 60, 90 triangle, a 45, 45, and 90 triangle. And there's really not much that we need to do with those, but I would like to use them as an opportunity to remind everybody that whenever we're looking at the unit circle here, all of our reference angles are those special triangle angles. This is 30 degrees, 45 degrees, 60 degrees, and over here, yes, it's 120. Yes, it's 135 degrees. Yes, it's 150 degrees. But all of these have a reference angle of 30 degrees, 45 degrees, 60 degrees. See, special triangles are very easy to solve for. And when we use the special triangle principles in the unit circle, it makes it very easy to solve for also whenever we're having to use the unit circle to solve things. So anyway, that's just a little bit of a reminder of why we use 30, 60, 90 triangles or 45, 45, 90 triangles in our unit circle. Here, just a reminder, whenever we are finding sine of theta, we're doing opposite over hypotenuse, cosine of theta adjacent over hypotenuse, tangent of theta opposite over adjacent. Now in unit 1, we did go over reciprocal functions, but it was on the review and we didn't even test over it. So we really haven't worked with it very much. Here are the reciprocal functions for cosecant. Cosecant is a reciprocal of sine, and cosecant of theta is the same thing as 1 over sine of theta. Secant is the reciprocal of cosine, and secant of theta is the same thing as 1 over cosine of theta. Cotangent is the reciprocal of tangent, and cotangent of theta is the same thing as 1 over tangent of theta. Now that's going to come in handy in about 5 minutes, I would say. Here you might want to pause the video and fill in some of these values, but I'm going to talk about them a little bit. We have gone over 30 degree or pi over 6, 45 degree or pi over 4, 60 degree or pi over 3 families when we started doing the stuff in the day 2 of our notes. We have gone over the sine value of all of these, the cosine value of all of these, and the tangent value of all of these. Today, we're going over the reciprocal of each of these respectively. So once again, the reciprocal of sine is cosecant. So if sine of 30 degrees is 1/2, the reciprocal of sine is cosecant. The reciprocal of 1/2 is 2. You just flip the number. If sine of 45 degrees is root 2 over 2, this one you need to be a little careful with. What is the reciprocal of square root of 2 over 2? It's 2 over square root of 2, right? But we cannot have a root in the denominator, so we need to rationalize. 2 times square root of 2. 2 times root 2. Those cancel, leaving you with the square root of 2. So that's why that's the square root of 2 there. All right, if sine of 60 degrees is root 3 over 2, then cosecant of 60 degrees is 2 root 3 over 3. I'm not going to go over how to find the reciprocals for the remainder of this particular section of the notes, but if you have any issues on, well, how'd you get root 3 here? And how'd you get root 3 over 3 there? That's a 3, by the way. It's not a very good one. Then feel free to see me in class and I'd be more than happy to show you how we got that value. All right, now what I'm going to need you to do is go ahead and go over to the second page of your notes. I'm doing this a little bit differently to show you how easy it can be if you're able to memorize this chart here. All right, so the first thing that they want you to find on the back side of the notes is secant of pi over 4. Now, what you're going to have to first try to understand is where, or what quadrant rather, what quadrant is pi over 4 in? Pi over 4 is in quadrant 1. Now remember, in quadrant 1, all things are positive. So we know our final answer is going to be positive. So what we need to do now is, if our denominator is 4, we want to use the pi over 4 family. which are going to be all of these values here. So our answer is going to be one of those values. We need the secant value. So where's the secant value? Right there. So your answer for secant of pi over 4, what is the secant value at pi over 4? It's positive root 2. Now go ahead and find cosecant of 2 pi over 3 in your notes. Now we have to think cosecant of 2 pi over 3. Now, if you don't know where 2 pi over 3 is, which coordinate it falls under, well, then you really need to work on, I'm sorry to say it, but you need to memorize the unit circle. You have to know where these values fall. 2 pi over 3 is in quadrant 2. What's the only thing that's positive in quadrant 2? Sine. And its reciprocal value, cosecant. Well, it wants us to find cosecant, so our final answer here is going to be positive. Now notice your denominator is 3. So we need the pi over 3 family. It's going to be one of our final answer is going to be one of these numbers. We just need to find the cosecant. So your final answer is going to be 2 square root 3 over 3. Okay, cotangent of negative pi over 4. What I'm going to do is I'm going to draw a coordinate plane. Now, if we were to sketch regular pi over 4, it would be here. But it doesn't want regular pi over 4. It wants negative pi over 4. So we need to go in the opposite direction. Here. Meaning we are in quadrant 4. What's the only thing that's positive in quadrant 4? Cosine. And its reciprocal, secant. But we're looking for cotangent. Well, if the only thing that is positive in quadrant 4 is cosine and secant, and we are looking for cotangent, we can go ahead and mark a negative symbol because our final answer is going to be negative. Our denominator is 4, so let's go to the pi over 4 family. Our final answer is going to be one of those values. We just need to find the cotangent, which would be 1. Okay, please find cosecant of 7 pi over 6 in your notes. Now cosecant of 7 pi over 6. It's right about here. That's in quadrant 3. The only thing that is positive in quadrant 3 is tangent and its reciprocal, cotangent. We're looking for cosecant. So our final answer is going to be negative here. Denominator is 6. So let's look at the pi over 6 family. We need to locate the cosecant value, which is here. Final answer, negative 2. Now, find secant of 3 pi over 2 in your notes. Secant of 3 pi over 2 is not in quadrant 1, 2, 3, or 4. So this chart is not going to help us. 3 pi over 2 is the same thing as 270 degrees, which would be here. Now on the unit circle, this is a bad drawing, but go with me. On the unit circle, 270 degrees, positive rotation would be here. That coordinate is 0, negative 1. Its tangency is undefined. So this is our cosine value. This is our sine value. This is our tangent value. Whenever you have to find a quadrant angle, here's how you find the reciprocal values. First, what you have to see is, well, what are they wanting us to find? in this case, secant. Well, what is secant's reciprocal? Cosine. So what we want to first find is what is cosine of 3 pi over 2? Well, cosine of 3 pi over 2 is 0. Now remember in your notes where it said secant is equal to 1 over cosine? Well, in order to find our answer here, we need to plug in this answer here. So if cosine of 3 pi over 2 is 0, we could take that 0, substitute it for cosine. And what is 1 divided by 0? Undefined. That would be your answer for secant of 3 pi over 2. I'm going to do examples 1A, 1B, and 2A. I highly encourage you, after example 1A, try and do 1B and 2A on your own. These are really not too bad. They just require some practice. And I have found that math, if you will work on it through trial and error, and then learn from the mistakes that you make, it makes learning math a little bit easier. So here's what we need to do for this example. Given a point on the terminal side of an angle, find the 6 trig values of the angle. Note, it is not important to know what the angle is, only what its trig function values are. They have given us a set of coordinates, -3, 4. Let's plot those on a coordinate plane. If we were to plot the coordinate -3, 4 on the coordinate plane, that's where would it be? And now from the origin, we can graph our terminal ray. Now, in order to get from the origin to this point here, we had to go left 3, we had to go up 4. Well, what we have done here is we have created a 90-degree triangle. So we can do Pythagorean theorem to find the distance from here to here. And now we can find our values here. Remember, so ka toa. Well, in order to use so ka toa, we have to have an angle theta that we're going to use as our reference point. And our angle theta is going to be here. It's always going to be the distance between your terminal ray and your closest x-axis, right here. So if so or sine is opposite over hypotenuse, sine of theta would be 4 over 5. Cosecant of theta would be 5 over 4. Cosine of theta, adjacent over hypotenuse, -3 over 5. Secant of theta, 5 over -3. Tangent of theta, opposite over adjacent, cotangent of theta. Before I would go on describing this one, like I said, I would love for you to pause the video and try it on your own. And then once you're finished, hit play, and then I'll show you. We're going to want to create a coordinate plane. Now we need to go, this is a positive √3. So from the origin, the positive x-axis is this way. So we need to go this direction, √3 amount. We would then go up from here to here once, creating a 90-degree triangle, and we can graph our terminal ray. And once again, we can use Pythagorean theorem to find our hypotenuse. Square root of 3 times square root of 3, because we're squaring something, right? So square root of 3 times square root of 3 is the square root of 9, and the square root of 9 is 3. Remember, angle theta is going to be here. So we're going to use this as a reference point to do SOHCAHTOA. Opposite over hypotenuse. Cosecant of theta would be 2. Cosine of theta, adjacent over hypotenuse. Careful with this one. Secant of theta would be 2 over root 3. But we cannot have a root in the denominator. And then tangent of theta, opposite over adjacent. Well, that would be 1 over root 3. And then cotangent of theta. Example 2, use sine of u equals 3 over 5, and u is in quadrant 1, to find the values of the other 5 trig functions. What we're about to do is very similar to the previous 2 problems, so try not to let the terminology confuse you a little bit. Now, our triangle is going to be in quadrant 1. Here's angle theta. It says sine of u is equal to 3 over 5. Well, sine is opposite over hypotenuse. Opposite over hypotenuse. So they've given a couple of our side lengths. Opposite of theta would be 3. Hypotenuse would be 5. Now we can use the Pythagorean theorem to find the adjacent side. And now we can fill in all of these blanks here. Sine of theta. They already gave us that. Cosecant. Cosine of theta, adjacent over hypotenuse. Tangent of theta, opposite over adjacent. Done. That's it for your notes. We're not going to worry about example 3 because they said solve for x. Well, where is x? Where's x? What's going on? Oh, here's one where we could actually solve for x, but you'd have to use a calculator. And this test is non-calculator. So don't worry about doing any of these. If you have any questions, come by and see me.